Good morning, students. So, as I said, that today we will talk a little bit about universal hashing, which is also the final part of this chapter on hashing. So, as I already said, that collision is unavoidable. So, whatever way you devise your hash functions, it's very difficult to avoid collision. But can we minimize it? Okay, so we try to do this using the concept of universal hashing, where what we do is we randomize the choice of a hash function from a carefully designed set of functions. Now, question is, what do you mean by carefully designed set of functions? So let's see how we can carefully design a set of functions. Let us say U be the set of universe of keys, and let H be a finite collection of hash functions mapping U into 0, 1, some m minus 1. Okay. So there is a universe of keys, okay, and H is a finite collection of hash functions mapping this universe into a set of numbers between 0 and m minus 1. Okay. In such a case, the set H is called universal if for x comma y in U such that x is not equal to y, we have some h belonging to h, hx is equal to hy. This is hy m. Okay. So that hx equals hy for some h chosen from capital H, this probability is h by m. Okay, of course, size of h by m. So in other words, the probability of a collision for two different keys x and y given a hash function randomly chosen from the set H is at most 1 by m. It cannot be more than this. Okay. So this is what is a definition of a universal hash function. Fine. So you have to ensure that the probability of collision for two different keys x and y, okay, given a hash function randomly chosen from capital H is not more than 1 by m. If you have such a set H, then that set H is called the set of universal hash functions. Okay. Now, the immediate question therefore is that how to construct such a set? Okay. How do we construct such a universal set of hash functions? So the question now is to create or construct a set of universal hash functions. So one possibility is as follows. Choose the table size, call it M, to be prime. Decompose the key, call it X, into R plus 1 bytes so that X is equal to X0, X1 up until XR, where the maximum value of any xi is less than m. Now let a be equal to a0, a1 up until ar denote a sequence of r plus 1 elements chosen randomly such that each ai belongs to the set 0 to m minus 1. So therefore, this immediately tells you that there are m to the r plus 1 such possible sequences. Right? Since each AI can be chosen from anywhere between 0 and m minus 1, and your any sequence A is A0 to AR, then you can therefore actually construct m to the r plus 1 such possible sequences. Now we will define a hash function HA with HAX is equal to 0 to R AI XI mod M. So this was the byte fragment, okay, the byte fragment of X and the corresponding weight value A that is chosen from anywhere between 0 to m minus 1. Okay. Now we say that a universal hash function can be defined as union of all these h's. Okay. This will have m to the r plus 1 members, one each for a possible sequence of A. So we have seen that A can be a possible sequence of A0 to AR, where each one of these elements AI is chosen from 0 to m minus 1. So therefore the number of sequences possible is m to the r plus 1, and therefore the for each corresponding sequence we will have an HA, okay, and the union of all these HAs is what defines the capital H. Now we will prove the theorem that the class H constructed so is a universal class of hash functions. How do we do this? How do we prove this theorem? The one that we have now just now constructed, we say that this is a universal hash function. Okay, this set H is a universal hash function. Now, how can we say this? Can we have a formal proof to show that this is true? So the proof is as follows. So let us say consider any pair of distinct keys, okay, let's say x comma y, where x is not equal to y, and assume that hx is equal to hy. And without any loss of generality, because these two guys x and y cannot be different, sorry, has to be different, let the difference be in their first bytes. Okay, first byte, that is x0 is not equal to y0. Okay, this is explicitly known. So the difference is, so since x and y has to be different, let us assume that the first bytes x0 and y0 are different. This will immediately make the two keys different from each other. So then for a fixed sequence, say A1, A2 up until AR, it holds that equal to 0 to R AI xi mod m is equal to 0 to R AI yi mod m, because hx is given equal to hy, okay, and this is what we have defined as our hash function to be. Hence, mod m should be equal to 0. This implies that a0 x0 minus y0 is equivalent to okay. So this is just a simple manipulation of the variables. Now, since m is prime, and x0 minus y0 is non-zero, and they are different, that is what we have already assumed. Hence, it has a unique multiplicative inverse modulo m. Okay, so x0 minus y0 should have a unique multiplicative inverse, okay, because it is non-zero and m is prime. So thus we can say that a0 is equivalent to inverse modulo m. So this is an expression that we arrive at for a0. And there is a unique a0 mod m which allows hx to be equal to hy. Okay. So then each pair of keys x and y collides for exactly m power r values of a, that is once for each value of each possible value of a1, a2 up until ar. Okay. So the x and y would collide for exactly m power r values of a once for each possible value of the or each possible choice of a1, a2, ar for this particular a0. Okay. So thus out of m power r plus 1 combinations of a0, a1 up until ar, there are exactly m power r collisions of x and y. Therefore, the probability that x and y would collide should be m power r by m power r plus 1, which is 1 by m. This implies that H that we have chosen is universal. As simple as that. So you start from a construction and you show that that construction is actually satisfying the condition that the probability that a pair of keys collide is equal to 1 by m, where m is the size of the table. Okay. And given a sufficiently large hash table, as you can understand, this probability of collision is almost negligible for choices of universal hash functions. Okay. So this is why universal hash functions are so popularly used in the hashing literature. So it's important to design universal hash functions which will guarantee that the collision between a pair of keys is as low as 1 by m, where m is the size of the table, and typically the size of a hash table in realistic applications could be like 10,000 or maybe even more, 100,000, and in such cases this probability is very, very low. So we stop here, and this was the end of the hashing chapter.